Students, welcome to physics classes. Today we are going to discuss the next application of Gauss theorem. Today we are going to calculate electric field due to uniformly charged infinite plane sheet. Students, when we give charge to a sheet, the charge is spread both the sides of the sheet. Second thing, what do you mean by infinite? Infinite plane sheet. Infinite plane sheet means it is not a very large sheet. It is not a very large sheet. Actually, a sheet is considered to be infinite sheet if the point are situated as a very small distance in comparison of size of the sheet. So if R is very small in comparison of the area of the sheet, then we say it is infinite sheet. Secondly, charge given this sheet is spread on both the sides. So point P may be on the right side or may be on the left side. It means that due to a thin sheet, we can calculate electric field on both the sides of the sheet. To calculate electric field at point P, we consider a cylindrical Gaussian surface of height 2r. R left and R right. So total height is a cylinder of height 2r and area of cross section ds. This cylinder is passing through the sheet of charge. It is going to pass through in this way. In this way it is going to pass. You can see. Then the charge enclosed by the Gaussian surface will be equal to charge on this area ds. The charge on this area ds. We have considered the surface charge density sigma, that is charge per unit area. Therefore, the charge enclosed by this surface ds equal to sigma into ds. Dear students, sheet is placed in the vertical plane and it is positively charged. That's why the electric field due to it will be radially outward. That is, the sheet is in YZ plane, but the electric field will be a what? Along x-axis. So due to this sheet, the electric field is along x-axis. The area vector is also along x-axis at the side caps of this cylinder. This is a cylindrical surface. Area is always taken normal to the surface outward. That's why for this surface, area is outward. For this surface, area is outward. That's why we can say the flux passing through this surface is what? E ds. E into ds. And the flux passing through this surface is also E into ds. So total flux passing through the side caps, electric flux passing through side caps is equal to what? To E into ds. And if we talk about curved surface area, for the curved surface area vector will be outward and the electric field is along x-axis. The angle between electric field and area will be 90. Or we can say the surface will not contribute to electric flux. So total electric flux passing through this Gaussian surface is equal to what? To E into what? ds. Now we apply Gauss theorem. Gauss theorem, integral E vector dot ds vector is equal to what? Q upon epsilon naught. integral E vector dot ds vector. What? It shows total electric flux passing through the Gaussian surface. That's why we have written here 2EDS is equal to Q is replaced by what? Sigma into ds. So 2E into ds is equal to sigma into ds upon epsilon naught. Or we can say E is equal to sigma upon 2 epsilon. Students, electric field is a vector quantity. Sheet is placed in this way. The electric field may be towards its left or may be towards its right, as I have shown. Towards right, towards left. That's why this formula can also be written in vector form. E vector is equal to sigma upon 2 epsilon naught into what? R cap. What is R cap? In 11th class, we people have studied unit vector gives the direction of physical quantity. So here R cap, unit vector, gives the direction of electric field, which is normal to plane and pointing outward. The electric field is normal to the plane pointing outward. Its meaning is that suppose this is a surface. If we shall see here, then the electric field will be in this direction, and if we shall see here, then the electric field will be in this direction. Basically, when we use this formula in vector form, then electric field towards right side is taken positive and electric field towards left side is taken negative. Means at this point electric field is positive and at this point electric field is negative.